gosh, it's been, I think, 3 years since the inaugural Reactive Summit, and I gave a talk there, and I haven't actually done that many talks in between. Life has somewhat changed for me. I was formerly at Lightbend, and there for almost 5 years. I'm having a great time, probably certainly the best job that I've ever had, I would have to say, working with that caliber of engineering. But for me, it got to a point where I felt that I personally had to seek something more meaningful and perhaps understandable, for people around me. So it's I'm not to say that Lightbend is not meaningful. I'm not trying to say that, but for me, I made a conscious decision to pursue the domains of agriculture and/or energy at that point in time. So the underlying theme to this, and hence the title, is that it's about searching for something meaningful, and in the context of React as well. I can show you how I can bring that to the fore, because 5 years at Lightbend, being absorbed, in the whole growing of the reactive things, if you like, all things reactive. This is something that for me codified my DNA. So I want to describe how we can bring that kind of thinking into these domains, into Australian agriculture, but we'll talk about a few other domains along the way here as well. So what happened was that I had made a conscious decision to leave Lightbend, working in the domains of agriculture, perhaps more so than energy at the time. And I didn't know quite how this was going to happen. In my last week at Lightbend, I was at a bank demoing some Lightbend things, and the chap that was looking after me, who might even be watching today, James Oosby, he and I got talking afterwards, and he mentioned that he was also leaving Lightbend. Not Lightbend, sorry, his bank. And I said, oh, so what are you going to do? He goes, well, I'm a farmer. And I said, no, you're not. You're a software engineer. He goes, well, I'm also a 5th generation farmer. And it turned out that we actually knew a lot of the same people. And so we really sort of hit it off there. And he said, well, look, next week I'm going to talk to the CTO of Cisco about IoT and agriculture and so forth. Do you want to come along? And that gave birth to a great relationship with Cisco, really pioneered by a chap called Kevin Block, who's the CTO of Cisco. He was the CTO of Cisco. And so, and that was really our start. And what they wanted was to see a platform developed that Cisco could promote as a product for IoT, with a specific focus on agriculture, but not necessarily tied to agriculture. And so using, I guess, my past experience influenced this, but one of their strong requirements was to be able to adopt communities, and in particular existing communities with technologies that had already proven themselves in this space. So they didn't want to reinvent the wheel here. This project was really more about bringing existing technologies out there with large proven communities with proven technologies. And so we targeted the JVM, and in particular, we write everything in Scala. We also support Java as well, and we of course adopted Echo Streams. Well, I shouldn't say of course, but perhaps given my background, that certainly came to the fore, and that has proven, I think, to have worked out really very well for us in the space, and we'll dig in perhaps a little bit more there as well. So first of all, in terms of what we're actually now doing, we have a brand that we have developed, or we are in the process of now starting to promote, called Farmify. And And it really, you know, it can, as it says here, we combine hardware and software, which is hosted at the edge on the farm, that can provide a farmer with a comprehensive view of what's actually happening around them. And this can all be done without reliance on the internet. You know, and that last sentence there is really perhaps a differentiator, perhaps. You know, when we think about a lot of solutions out there in this space, we often think about the cloud being available, but for Australian geography, and in fact, not just Australian geography, but around the planet, when you are in rural communities, it's quite often the case that the internet is unreliable. So this was pretty important from the outset to actually achieve this goal. And you know, why is this important? Is that farming is getting harder. It's not getting easier. And you know, so there are from some strong you know, reasons there. You know, but you know, what we're also finding was that farmers weren't avoiding technology. They were adopting technology conversely. But they were adopting a lot of different technologies that were quite disparate, and that were building these silos of data. So again, with the Cisco project, it was all about really what can we do here to bring this data together. And the sort of use cases that we're actually looking at, you know, we didn't actually going into this, we didn't quite understand what the use cases would in fact be. But I can tell you that, I mean, water management always comes up, you know, it's a big issue, you know, really no matter where you are on the planet, but particularly here in Australia as well, to make sure that you have enough water on the farm is very, very important. One day without water and your livestock can die, you know, it becomes that critical. And so what we find is that a lot of farmers don't feel as though they can even leave their farm. You know, so what can we do therefore as a technology provider to help alleviate some of those concerns? Electric fence monitoring is also a big one, and you know, these things perhaps might seem technologically mundane, but they're incredibly important. And you know, for electric fences, properties of several thousand acres can, you know, your fences can be several kilometers away. And so to go and inspect the fences regularly takes a lot of time, takes a lot of fuel, consumes employee hours and so forth, right? So we've been able to not eradicate that, but diminish it significantly, you know, so that, you know, there are some pretty obvious savings and a lot of peace of mind for the farmers. And then something that's happening more and more is livestock health performance as well. And I might come back to circle back to that one a bit later because it's quite fun. Okay. And then the way we provide it is that, you know, one of the most difficult things for farmers is knowing where to start. They're willing to give things a go. So really what we're about is making that easy. You know, we brought these things together. We haven't necessarily invented everything ourselves. Okay. And so, you know, you get to go to nice places. And so, you know, perhaps another way of summarizing this is that we are out there to empower farmers, you know, to give them the tools and the means to actually instrument their farms. And so what we do here, and that's me, by the way, I'm standing on a quite a tall hill. It's the highest point of this particular property. And we've instructed the farmer there on how to go and build a tower. Now, my background is in software engineering, not building towers, you know, but I can tell you it's fairly straightforward. You know, you put a post up and you put a fence around it so the livestock can't get in there. Perhaps the most challenging aspect of this has always been the power management side of things. That's a big learning from everything. And this actually comes back down to energy efficient computing as well, which is another sort of pet subject of mine. But you know, you typically end up with solar panels and batteries and so forth. And I can tell you that one of the biggest problems out there is is bird droppings. Bird droppings on solar panels really diminishes the efficiency, of course, of the panels. Now, one interesting aspect of this, we're using a low-powered wide area network in LPWAN. We've been using a technology in particular called LoRaWAN, and that gives you the ability to have these little sensors scattered over a property and that are able to communicate several kilometers on a couple of very small AA batteries lasting well over a year, definitely. So very impressive technology. And those mountains that you can see in the distance of this particular photo, I can tell you they're about 30 kilometers away. And you might be surprised to learn that you can actually get a signal from this tower to those mountains 30 odd kilometers away, again on these little sensors that consume very little power. So quite fun. And then also from this particular tower, we're using directional Wi-Fi to send probably over about 50 on a 50 megabit link back down to the property, which was 3 kilometers away. And so this is again one of those extreme sort of situations that we were able to deal with, and that's still in operation. It's going pretty well. So 3 things that I consider to be really important. And again, you know, the theme of this is how can we seek meaningful things to apply our software engineering skills to? First of all, the technology has to be interesting. And I want to, you know, as part of this, sort of emphasize that working in a domain of agriculture might sound kind of dull, perhaps, or for some people, but it's actually as it can be as bleeding edge as any other domain that we may be talking about here at this summit today. The people always must be great to work with, you know, but then the third thing here is that the work itself must be meaningful. Now, these are the things that I find drive me, but in the course of actually doing this over the last couple of years, I've had many software developers, you know, from many networks that I was able to establish through working on open source at Lightbend, you know, from the Play team, from all the other things that I got involved with there. And, you know, engineers coming to me saying, hey, you know, what's going on? You've got some work, you know, because I really want to get out of bed in the morning and do something meaningful. Now, just to put things in perspective here a little bit, a couple of years ago, Stack Overflow conducts a survey every year, in fact, but there was one a couple of years ago where they had, I think, 64,000 respondents. And it turned out that only 0.6% of those respondents stated that their company that they're involved with worked in the domain of agriculture, forestry, and fishing combined on the planet. So clearly there's an issue here, and I'm not suggesting that we should all give up on, you know, writing the next social media app or the next database or the, you know, developing more software tools and so forth. These things, you know, some of those things are certainly important to do, but for me, it feels like there's an an imbalance of talent out there on the planet. And I can say that, you know, what we've been able to do here is that, you know, farmers have found this solution to be indispensable. You know, if the system becomes unavailable to them, we get to hear pretty quickly. So, you know, that's perhaps a good sign. So how does the Reactive Manifesto apply to all of this? You know, if we take the major pillars here of the Reactive Manifesto, first of all, resiliency. We don't even need the internet, you know, and when we say that to farmers, they go, well, that's great because we don't have it, you know, and that sounds kind of funny, you know, but they do have it. It's just not necessarily reliable quite often. And I want to emphasize here that my good friend Jonas Boner said once to me, yeah, and Jonas, you have to be very careful because everything you say to me tends to kind of stick. You're almost shaping my DNA and have done for many years now. But he said to me that without resiliency, nothing else matters. And I I completely agree. I mean, I've felt that, for many years now, and it's so important. And particularly in the IoT domain, I can tell you that everything fails all the time. So your ability to face failure and handle that with consideration up front is incredible. It starts on day one, writing the first line of code. It's not an afterthought. You have to start with this mindset. Being responsive is the system is always, as I say, it always stays up and available without the internet. No, naturally, if you pull its power, then it's going to go away. There's only so much we can do. But certainly the disappearance of common things like network connectivity to the cloud does not halt the system at all, right? So we've got a lot of situations now where we've been able to demonstrate that. Being elastic, in a sense, with the farms that we've got several customers now. The farms, and they're big customers, big farms. We've effectively created this virtual data center with our edge nodes. These edge nodes can indeed communicate with each other as well. So we don't rely on the cloud, even from a topology perspective. We certainly store data in our cloud, and we can provide a user interface from there as well. We can also provide the same user interface from the edge too. But we can also do things like replicate data stores between the different edge nodes as well. So even if a farm is unable to let's say, access another farm's data, which should certainly be the case, that they should not be able to do that, then we can still push the data to that edge node. And we can do that because we encrypt everything. And unless you have the keys for that data, it's just garbage. It means nothing to you as well. So we don't rely upon cloud providers providing us with object stores so that we can provide backups and so forth. We can actually replicate to any of these nodes. Everything is a message in IoT. We'll come back to that one a little bit later as well. But messaging is, again, it's one of those things right from the very beginning, from writing that first line of code. You have to think about everything as a message, that this message may not reach its destination, even if it's even within process on a different core. It's not guaranteed to sort of get there. Now, the chances of it not getting there are pretty slim in that situation, but certainly starting with that mindset, certainly when you get out of process, it's very important to consider. It's absolutely quite normal possible for another process to not be bound waiting on a port, for your messages. So you have to consider this from day one. Now, more recently, we've had the release of the reactive principles. So I thought maybe it'd be useful to talk about, again, how we slice and dice this, how we do what we do in the context of the reactive principles. Now, these principles, I must say, what an incredible contribution these are to our industry. I think that you can use these principles to go into any new employment style of situation, or even to evaluate your own organization, and come up with the ability to do an assessment on how well this organization is doing. On where are our gaps, where do we need to improve. So I personally believe that these principles are going to become perhaps even more important than the Reactive Manifesto itself. So if we talk about each one, staying responsive, we touched on this. So the edge continues to stay up. I can tell you that you don't have to be far outside of a rural center, certainly here in Australia, where you only need one or two hills in the way of a mobile phone tower and suddenly you've got no signal. And we've certainly found that with customers who are close to these major rural centers, but only 15 kilometers away, and have very poor or unreliable 4G coverage. All right, so you have to be able to work in that context. But also, we can stay responsive even if the edge has gone offline for some reason. Let's say even there's no power. I mean, the power can also be unreliable in these situations. Then we can still provide service through our cloud. So we have multiple points at which you can access data. Now, of course, you're not going to get updates in the cloud from your sensors. There's no magic here, but at least that ability to continue on and see the data that you've got and analyze that data you've got is there. Accepting uncertainty. What I thought about, I wanted to talk about here was you can have multiple of these low-powered wide area network towers that I showed you earlier. You can have multiple of those. Now, radio waves are indiscriminate. They're not looking for a particular destination. They're not directional in our situation. They're basically broadcast. So if you have more than one tower on your property, then which you might do, to extend coverage in certain corners of the property, then you will get those messages from those devices potentially twice, right? And obviously n times depending on the number of towers that you've got. Now, we've seen other solutions out there attempt to cope with this by deduplicating fairly early. We don't. And so we accept this uncertainty itself. We let these messages in, and we deal with deduplication at the point of consumption in the UI itself, because we can make pretty easy, safe sort of decisions there. We know, for example, that if an IoT sensor is transmitting once per hour, and we have 2 messages within that hour time frame, then with the same values indeed, then one of them can be discarded. And so it's certainly an application concern, but deduplicating at the point of consumption is how we've been able to successfully manage that kind of situation and that sort of uncertainty. In terms of embracing failure, when it comes to IoT, if you ever need a use case to test that failure, then go to IoT. This I saw Kiki actually tweeted something to this effect the other day, and it is so true. When a device transmits from one place to another, you can expect data loss itself. So there are some tricks here that you can employ. First of all, you never look for a confirmation or an acknowledgement. So IoT devices should, in general, depending on what they're doing, but certainly in our context, they emit their data, their observations on a best effort basis. But what they also do is, in some situations, is not only transmit their current value, but their previous value, right? Because they can probably do so. We're talking about very small packet sizes of about 12 to 20 sort of bytes. That's right, bytes, not K, bytes. And, but there is still the opportunity of transmitting not just the current value, but the previous one that device emitted. Now, of course, if you miss 2 messages, then this doesn't really help you, but you tend not to. You might miss 1, right? Which is the common scenario, but it's unlikely that you miss multiple. This is what we found. So you can transmit messages, and this is an application design consideration for sure. Asserting autonomy is, how we have this situation in our use case is that we can, for example, provision devices in the cloud, and these events are then pushed to the edge, to the farm, when the farm becomes available. And these events can only be sourced from the cloud itself. So when designing your event first driven system, you consider where the source of those events can be. Now, let's say, for example, that we want to configure a device's name. Now, that can happen either at the edge by the farmer, or it can happen in the cloud. And given, let's say, timestamps are unreliable, because indeed they are unreliable, and you get clock drift and so forth, you may well end up with a situation where you've changed the name in the cloud, and you've also changed the name at the edge itself. And so you need to make an application decision, right, as to which one is going to supersede the other one. And it's kind of like CRDTs, which other talks may have talked about. There's the ability to be able to distinguish these two types of event and then make a decision. You're always able to make a decision. We, for example, make the decision in our case that if the farmer sets the name, that's more important, and that will override any cloud-based setting as well. So that's how we've gone about asserting autonomy there as well. And so again, I think it's very important when designing your events to consider the source of those events as well. They should only be sourced from one place. And when you start thinking about it in those terms, facts become fairly easy to reason about. So you have one event for name changed in the cloud and another one for name changed at the edge, rather than just leverage just one event in total. Tailoring consistency, for us, everything is eventually consistent in our system. Our experience is that the single point of consistency is booting up the system in the first place, where a human is involved. And, in terms of tailoring consistency, this is also an application concern. This is something that bleeds through into the user interface of the application as well. It's something it's not something that you can just rely upon the system providing you, on tooling providing you. These are design decisions that you build into your user interface itself. Certainly with our user interfaces, they are all event-driven. They're web-based, they're event-driven, and we rely upon service and events, for example, to signal that changes have occurred at the back. And they can occur at any point in time. Decoupling time, well, of course, it goes without saying, hopefully, that we don't block on any operation. When you consider that a message is emitted from a device several kilometers away from a tower, it's then received at a tower, and that can actually take 1 to 2 seconds. And then from the tower to the computing device, which may be, for example, over directional Wi-Fi, and then from the computing device to the cloud. These things are all decoupled in time. Everything, the events are persisted to a durable queue. It's similar to Kafka. We're actually using Confluent queue because we're working in highly resource constrained environments. And Kafka wouldn't fly in these environments, unfortunately. But it's very similar in principle, where we have a log that we append to and that various other services can consume from that log, tell that log at their own pace, and record their offsets, once they're satisfied that a message has been delivered to where it needs to be delivered. And so we've been able to decouple time quite nicely. And a really nice example of this for us is that we've actually been able to fly a little bit of hardware around on the bottom of a drone. One of our customers is in fact a drone company, and then collect sensor data as we're flying around the property. And then when it's docked, or it can establish a Wi-Fi connection again. When it comes back to base, then it's able to replicate its data to our cloud itself. So I think that's a pretty good example of decoupling time. Decoupling space, what I want to say there is Australian geography is wide and far. So we certainly decouple space. We don't we don't obviously rely on everything being in the same place itself. We've got data on the sensors. They have a certain degree of storage, certain amount of storage. The gateways themselves for receiving LPWAN signals, they've got a certain amount of storage and they can store them forward. The edge node devices have their own storage. The cloud has its own storage as well. So all these things are quite distributed and decoupled. And then handling dynamics. What I want to say about this, we talk about elasticity and the ability to scale up more nodes and indeed scale down nodes as well, which is also very important. And there seems to be a lot of enthusiasm as well for being able to do this dynamically. What I want to say here is, although, we certainly have, from an architectural point of view, the ability to add nodes. We are horizontally scalable, is don't get lazy. You've got to dimension these systems. You've got to understand, what order of magnitude that you're looking at in terms of your throughput, and your storage requirements and so forth. I can tell you, I was a bit concerned, with our append-only durable queue style situation. It had no built-in ability to clean up its events after it was sort of going through them. And so I just started to work this out. And once I, dimensioned it, we dimensioned it, we worked out that, in fact, you can probably on a small 1 terabyte USB drive at the edge, you can actually store about 100 years worth of data. So, once you start thinking about it in this way, then, once you start dimensioning it, that or storage is certainly not a big issue, but you do have to think about it. You can't just let these systems you can't rely upon them like Kubernetes or whatever, doing everything for you. It's definitely an application concern. So that brings me to pretty much the end of my presentation. I just wanted to say here, this is in fact our website. Actually, that bridge there is very close to us. It's very local. It's not just one of those pictures picked out from a gallery. But what I want to say here is our mission statement is starting to change. So we've had this quite a strong focus on agriculture as a domain. And that continues for us, certainly, but we found ourselves, particularly this year, it's been a very interesting year, of course, for many people. With the advent of COVID, one of our clients actually came to us and asked us if we could actually create a digital hand washing device, an Android-based device that could be mounted above basins in hospitals and schools and guide the user or the person to wash their hands and record their compliance and then be able to distribute this clients. And you know what? We were able to leverage the same technology that we developed in conjunction with Cisco, which incidentally they transferred to us. And we're able to use that in such a way that we now have a digital hand washing network in place, and we're actually developing sensors around hand sanitization, recording their uses, and using other technologies such as Bluetooth, low energy, and Bluetooth mesh to distribute this information. And all that I've talked about today applies to this domain as well. We have another project associated with the University of New South Wales for a couple of subantarctic islands off New Zealand to instrument